Welcome to the third video in the series introducing the Energy Policy Simulator, or EPS. This video highlights the tool's inner workings. Other videos in this series summarize the simulator, its web interface, its input data, and how to adapt the EPS to different countries or regions. Links to all of these videos appear in the comments field. The EPS is built using a program called Vensim, a programming environment for developing system dynamics computer models. The EPS itself is free and open source, but Vensim is commercial software. Vensim comes in 5 different configurations with different combinations of capabilities and price. The EPS has been designed to be used with the free Vensim model reader. Thus, it is free to use the EPS, to edit its input data, and even to adapt it to new regions. A few advanced features, such as policy optimization or policy contribution testing via scripts, require Vensim DSS. The other 3 configurations are either not compatible with or not recommended for use with the EPS. To use the model, the first step is to download Vensim Model Reader. In a web browser, navigate to vensim.com/free-download. Fill out the form on this page, being certain to change the product radio button from Vensim PLE to Model Reader, and to choose your operating system. After you click Download Software, you will receive an email with a link to download an installer for Vensim Model Reader. If you're following along, go ahead and install the software now. Once Vensim Model Reader is installed, you will need to download the EPS. You may begin at the EPS homepage, www.energypolicy.solutions, and select the country of interest. In this video, we will use the United States version of the EPS. From the country landing page, choose the Learn More button to access the EPS documentation. For some countries, a download button will be available on this page. For the US version, we must navigate to a separate Download page. The Download page includes instructions for installing Vensim Model Reader and the EPS. We've already installed Vensim Model Reader, so we can click on the Download the Energy Policy Simulator button. The model package is downloaded as a zip file. It is important that you extract the contents from the zip file before proceeding. Although it is possible to open and view the model when it is still inside a zip archive, you will encounter an error if you try to run the model, because running the model produces an output data file, and Vensim cannot write an output file directly into a zip archive. Inside the model folder, you will see a number of items. The input data folder contains the data that define the country or region represented by the model and govern various aspects of model behavior. The contents of this folder are the subject of the 4th video in this series. The next 3 files are Python scripts. Python is a programming language, and these scripts extend the core capabilities of the model. The next 2 files are the EPS program itself. The one with the .vpm extension is the one compatible with Vensim Model Reader. Note that if you do not see file extensions on your computer, you can configure Windows or Mac OS to display them. The graph definitions file sets properties of graphs that appear inside Vensim. The license file includes the text of the EPS's software license, the GNU General Public License, or GPL, version 3. Output vars to export is a file that works in conjunction with the Python scripts mentioned earlier. The README file includes basic information about the tool and where to find documentation. The next 3 files are scenarios, that is, saved policy packages, We will create a scenario together later in this video. The web app data file is used to help deploy the model online. You will not need to edit this file unless you are adapting the EPS to a new country or region. Opening the EPS in Vensim Model Reader takes you to the Structural Overview page, which displays some useful information, including a diagram of the model's high-level structure. This was discussed in the first video in this series. There is also a key to the colors of the variables you will see elsewhere in the model. The menu in the lower left allows you to navigate between sheets of the model. Sheets are like tabs in a spreadsheet program. They help to organize the model visually, but they do not limit which variables may be used in any particular equation. The major sectors, transportation, electricity, buildings, and industry, each have 3 sheets, one for the main set of calculations with policy effects, one for the business as usual or BAU case, and one to calculate cash flow changes caused by differences between those 2 cases. Other model components handle all of their calculations on a single sheet. We do not have time to review all of the sheets in this video, so I'm going to use the Transportation Main sheet as an example and teach you how to read the model structure. Then you can explore the model on your own. Most sheets in the model, including this one, contain the model's calculations. Each item with one or more arrows pointing towards or away from it is a variable. For example, transportation sector fuel used, fuel cost per unit cargo distance, and SYVBT, Start Your Vehicles by Technology, are all variables. Every variable contains one or more equations, which tell the model what numerical value or values the variable will hold. If a variable has an arrow pointing at it, that means that the variable at the other end of the arrow is used in this variable's equation. For example, last year fleet average fuel economy is one input to the calculation of fuel cost per unit cargo distance. Some variables are in pink or purple boxes. These are input data variables. They don't have arrows pointing at them because they read their data from files that are distributed with the model. You can edit these input data outside of Vensim in order to change model parameters or to adapt the EPS to a new region. That is the topic of the next video. Some variables are in gray text and surrounded by inequality signs. These are called shadow variables. A shadow variable is a pointer, also known as a shortcut or alias, to that variable wherever it exists within the model. Some variables are in gray boxes. This is a visual signal that the variable is an intermediate result used elsewhere in the same part of the model, usually on the same sheet. Some variables are highlighted in blue. These are policy variables, and they are set by the model user when designing policy packages. In most sheets, calculations are organized into different sections, with headers indicating the purpose of that section. For example, the main purpose of this section of the model is to calculate the cargo distance transported, that is, the number of passenger kilometers or freight ton kilometers of travel demand for each vehicular mode. Sections are laid out left to right or top to bottom, generally following the logic flow of the calculations, though sometimes it is necessary for an earlier stage in the calculations to use a variable calculated at a later stage, potentially with its variables delayed by one time step. This is called a feedback loop and is a common feature of system dynamics models. Near the end of most sheets, you will find variables in orange boxes. These are important results and are typically used elsewhere in the model. For example, transportation sector electricity demand is summed with other sources of electricity demand and then used as an input to the electricity sector to determine how much power must be generated. Most variables in the energy policy simulator are array variables, or what Vensim calls subscripted variables. This means they contain more than one value. In fact, they contain a value for each element of the array. For example, the variable transportation sector pollutant emissions is subscripted by pollutant, and it contains different values for different pollutants, such as carbon dioxide, methane, and so forth. Variables often have more than one subscript, which means they have more than one array dimension. For example, a variable that defines a property of different vehicles may be subscripted by vehicle type and by vehicle technology. As a model user, the most important sheet is the Policy Control Center. This is where we set policies and design policy packages. The variables are policy levers, which are used to enable and set the stringency of different policies. They are divided up by sector. Many policies feature an icon showing the letter S inside a pink box. This indicates that the policy lever is subscripted and needs to be set separately for its subscripted elements. For example, different carbon tax rates can be levied on different sectors, including the transportation sector, the electricity sector, and so forth. 3 other sections are worth noting. The Research and Development, or R&D section, contains levers that accelerate R&D progress, above and beyond the R&D included in the business-as-usual scenario. This can make equipment cheaper or more fuel efficient. These levers are technically not policies, but they are set like policy levers. The Control Levers section features variables that toggle model behavior, usually used to help adapt a model to a new country or region. Unlike policy and R&D levers, control levers affect both the business-as-usual case and the policy case. The Policy Implementation Schedule selector is used if you have customized the implementation schedules for one or more policies in your policy package. This process is described in the next video in this series. There are 2 ways to run the model in Vensim Model Reader. The Simulate button runs the model once and then stops. The Synthesim button enters an interactive mode in which you can change policy settings and the model is rerun after every change. This mode also makes it easy to load and save policy scenarios. We'll be using Synthesim mode in this video. When we click the Synthesim button, Vensim shows a slider below each policy variable. All policies start set to 0. Vensim now shows data in several graphs that appear below the policy levers. It is possible to set policies by dragging the sliders below the policy variables. For example, I can set the % change in electricity imports to any value from 1, or plus 100%, to negative 0.5, or a 50% cut in imports. There are 2 problems with setting policies this way. First, it is hard or impossible to select the policy setting you want with precision unless the desired setting is the upper or lower bound of the slider. Second, for subscripted policies, those with the S logo in the pink box next to them, moving the slider only changes the first subscripted element of the policy. Recall that the carbon tax policy is subscripted by sector, and the sectors are the transportation sector, the electricity sector, the residential buildings sector, and so forth. If we move the carbon tax slider, we are only changing the carbon tax on the transportation sector, leaving the other sectors unaffected. This is typically not how we wish to use the carbon tax policy. The better way to set policies is to click on the track that appears behind each slider. Then, For a subscripted policy like the carbon tax, we click on the Ed button in the small box that pops up. This allows us to enter values for each subscripted element of the policy by entering the numbers using the keyboard. Vensim does not limit us to any maximum or minimum value, although entering nonsensical or very extreme values might not produce meaningful model results. Let's enter a carbon tax rate of $50 per ton CO2e applying to the transportation, electricity, residential buildings, commercial buildings, and industry sectors. We then click Close and OK to close the dialog boxes. The model now shows our policy package in blue diverging from the business as usual or BAU emissions trajectory. Suppose we like the policy scenario we just created and we want to save it for later. We click the Save button in the button bar, give it a name, and save it into the same folder as the model. The scenario is saved as a file with a .cin extension. Although the extension may be unfamiliar, this is simply a text file, and we can open it in a text editor to see the scenario's contents. Each of our policy settings is saved into the scenario and can easily be viewed and modified here. To set all policies back to 0 and begin designing a scenario afresh, we use the Reset All button. To load a previously saved scenario, we use the Load button. In addition to the scenario we just created, 3 scenarios are included with the U.S. Energy Policy Simulator. These are the same scenarios that are included as reference scenarios in the model's web interface, shown in the previous video in this series. Let's load the EI scenario, which contains policies recommended by Energy Innovation. Vensim asks if we wish to reset on-screen changes. If we click Yes, all our policy settings are reset before the loaded scenario's settings are applied. If we click No, the settings of the new scenario are merged with the current policy settings, if any, creating a hybrid scenario. Right now, we don't have any current policy settings, so the 2 choices will produce the same result. Generally, we will want to click Yes to reset changes when loading a scenario. The scenario is now loaded and all of its policy settings are applied. There are a couple ways to view our results. First, we can look at the graphs built into the EPS. 10 appear on the Policy Control Center sheet, and others appear on different sheets of the model. The second way to obtain results is to ask Vensim to generate graphs or tables containing the values for any of the variables in the model. There are more than 1,000 variables, so you have access to far more data than can be viewed through the web interface. Let's use the transportation sector pollutant emissions variable as our example. We can select the variable and click the Table button to see the contents of the variable. This variable is subscripted by pollutant, so it has a value for each of the 12 pollutants in each time step. In case you are wondering, the value is 0 for F-gases, which are used in automotive air conditioning systems, because the EPS assigns F-gas emissions to the industry sector which produced those gases. Small buttons in the upper left portion of the window allow us to copy the data to the clipboard or to save it as a text file so we can easily import the data into a spreadsheet program. We can also ask Vensim to generate a graph of the variable by clicking the Graph button. Notice that, although the graph contains 12 data series, one for each pollutant as shown in the key, only one line is clearly distinguishable. This is because this graph shows the quantity of each pollutant in grams, and the amount of CO2 far outweighs the amount of the other pollutants. Suppose we want to see the other lines more clearly. we can hide the CO2 line, and Vensim will rescale the graph to accommodate the other lines. To do this, we click this button to open the subscripts control pane. This pane shows all of the different subscripts that are used in the EPS. Each subscript is used on more than one variable. We activate the Pollutant tab, then deselect the CO2 pollutant. Now, when we recreate the graph, the CO2 line is gone. Instead, we can clearly see the lines for CO, NOx, and VOCs. We can repeat the process, removing those 3 lines, then regenerating the graph. Now we can see lines for all of the remaining pollutants. Mousing over the entries in the key highlights the corresponding lines on the graph, helping to clarify which line is which. This concludes our look at the inner workings of the EPS. There's a lot to discover, so explore and see what you can learn. As a reminder, this is the 3rd video in a series about the EPS. The other videos provide an overview of the simulator, a tour of its web interface, and a look at the tool's input data and the process of adapting the EPS to new regions. Links to these videos can be found in the comments field.